In this lesson, we will discuss 4 examples on multiplying polynomials. We're going to start with multiplying a monomial and a polynomial. Remember, a monomial is a singular term that might have one variable, but there's no addition or subtraction sign separating it, whereas a polynomial is more than one monomial being combined with a subtraction or addition signs. Example A, 3x squared times x to the third plus 4. We need to distribute 3x to the second to both terms. Well, 3x to the second times x to the third. Remember, when we multiply exponents, my trick is to add the exponents. So 3x to the second times x to the third is going to be 3x to the fifth. 2 plus 3 is 5. Next, I have to take 3x squared times 4. Well, 3 times 4 is 12, and the x squared just comes along for the ride. It's in standard form, highest power down to the lowest. Now, example B is a little more complicated, but we take it one step at a time. So AB times a to the third. I can multiply the a's together. So a to the first times a to the third becomes a to the fourth, and then we have b that comes along. So now we have to do ab times 3ab to the second. Now if there were a number out front here, I would multiply it with the 3, but our number is 1, so 1 times 3 is 3. A times a becomes a to the second. B times b to the second becomes b to the third. One more term to distribute. AB times minus b to the third. So we're going to have minus, a is going to come first, b to the first times b to the third. 1 plus 3 is 4. So we have ab to the fourth. Now that is a monomial and a polynomial. We've got 2 more examples to discuss. There are 2 ways to do this, and I'm going to show both ways in different examples. This is an example of we have a polynomial with 2 terms and a polynomial with 3 terms, in which we can use the unabbreviated FOIL method or distributive property and multiply each term in the first polynomial with each term in the first. Each term in the first multiplied with each term in the second. So here's our example. We have x minus 2, 1 plus 3x minus x squared. So in order to take care of our foiling method, or just thinking it through this way, where we put arrows, let's start off. I need to multiply x times 1. That just becomes x. Then I've got x times 3x, which is a positive 3x to the second. And we have x times negative x to the second, which would be minus x cubed. Change colors to show you this. Now we have negative 2 times 1. That becomes negative 2. Negative 2 times 3x. That would be minus 6x. And negative 2 times negative x squared would be a positive 2x squared. Now we can go through and combine our like terms. So I'm going to start with the x to the second powers. Positive 3x squared, positive 2x squared. Actually, I almost made a mistake here. We should start with the x to the third. So the first term I'm going to rewrite is x negative x to the third. Now I can combine my powers of 2. 3x squared plus 2x squared becomes 5x squared. So I'm done with these terms. And now I've got an x. 1x minus 6x becomes a minus 5x. and my last term is just minus 2. So after we get done distributing each term, we go through, combine the like terms, and write it in standard form for the highest power down to the lowest power. So this is one method you could use. The next method, next example, is going to get a little more complicated. We have a 3-term polynomial times a 3-term polynomial. And I'm going to show you the box method with multiplying these. Either method can work. I could still use this method to multiply this 3 by 3. But I'm going to show you the second way of doing it, the box method. In the box method, we have a 3 by 3. So I need to leave enough space for 3 terms on the top. I can write those in. Let's use the first one. It doesn't matter which one you write up top. So let's go x squared, 3x, negative 5. And then I need enough room for 3 terms down the side. So let's go with x squared, negative x, and 1. So when I multiply these through, I'm going to be multiplying the top row with the bottom row and filling in the middle. So we have x squared times x squared becomes x to the 4th. X squared times 3x becomes 3x to the 3rd. X squared times negative 5 becomes negative 5x squared. Now let's go the middle row. Negative x times x squared would be a minus x to the 3rd. Negative x times 3x would be in the minus 3x to the 2nd. Negative x times negative 5, that's a positive 5x. And we're down to row 3. 1 times x to the 2nd is just x to the 2nd. 1 times 3x is just 3x. 1 times negative 5 is negative 5. Now the great thing about this is you'll notice as you use your diagonals, those are the like terms that you're going to be combining. Almost every time it will work out this way in a 3 by 3. So we're going to rewrite this polynomial as x to the 4th comes first. I'm going to combine negative 1x to the 3rd plus 3x to the 3rd becomes a positive 2x to the 3rd. Now we've got negative 5x squared minus 3x squared, that's negative 8, plus 1, negative 7x squared. 3 plus 5 is 8x, and then we have minus 5. So you choose your method. You can either use our distributed method, or you might call this foiling, or you can use our box method when we multiply polynomials.